Okay, so we're going to look at another kind of formula for dealing with finding elements for a sequence. I don't want to break it down into arithmetic and geometric at this point, so I'm just going to use variables to represent the elements. So if the first term of a sequence is A, and the second term is B, third term is C, and so on, until eventually you end up at some nth term. We have a formula, a general formula for both arithmetic and geometric, to take us from the first term and point us to any term we may choose. And these are general formulas. But sometimes we want to be able to go from one term to the very next term, and then from that term to the next, from that term to the next. So knowing what E is will tell us what F is, and knowing what F is will tell us what G is. I forgot the alphabet for a second. And knowing what G is, on and on and on until you get to some term that you want. So sometimes what we want to do is start with the first term and build the entire sequence. Fortunately, we have a formula for that, and we call it the recursive formula. Because finding some nth term requires that we know the n minus 1th term. I know that sounds a little unwieldy on the tongue, but it just means that in order to find any given term, you need to know the term beforehand so that you can identify the pattern and build a sequence from the beginning until you have as many numbers as you want. So let's look at actual sequences now. I'll break it into arithmetic and geometric at this point because the formulas are a little bit different from each other. So let's start with an arithmetic. And I'll start with the first element of 1 and use a common difference of 2. So 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, 9, on and on and on. And I'm going to write them vertically, so I'll say that the first term, the value of the first term is 1, and so the a sub 2, or the second term, is 3, and a sub 3 is 5, a sub 4 is 7, and a sub 5 is 9, and on and on and on. And then we want to look at a way of writing a sub 2 using the value of a sub 1. So I know already that the common difference is 2, and so I think I'm going to use that. If I wanted to write the number 3 in an arithmetic, which means addition, using addition, I could say that 3 equals 1 plus 2. Easy enough. Then for the third term of 5, notice that 5 equals a sub 2, 3 plus 2. And then the fourth term, 7, which equals the previous term, 5 plus 2. And the fifth term is the previous term, 7 plus 2. And so for each term, I use the previous term and add 2, the previous term, add 2, the previous term or the previous value, add 2, and so on. So I could actually say that the second term is the same as a sub 1 plus 2. The third term then is a sub 2 plus 2, right? Because we're looking at 3 as a sub 2. The fourth term is a sub 3 plus 2, and the fifth term is a sub 4. Let's try that again, a sub 4 plus 2. And so we see that for a recursive formula, the nth term, whichever term we're looking for, is always going to be equal to the previous term, a sub n minus 1, plus whatever the common difference is. So let's set up and look at a geometric in exactly the same way. Again, I want to start with 1. I'm going to use 3 for the common ratio. So 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, and so on. So if I set it up exactly the same way I did for the arithmetic to understand it, I can say that the first term is 1, a sub 2, or the second term, is 3, a sub 3 is 9, the fourth term is 27, and the fifth term is 81. And now I want to do exactly what I did before. I want to write 3 using multiplication because it's geometric. I want to write the number 3 using the previous term. Well, the previous term is 1 times 3 equals 3. Then on to 9. I want to write 9 using the previous term, which was 3, times, what would I have to multiply 3 by to get 9 is 3, and so on. So 9 times 3 is 27, and then 27 times 3 is 81. So just like I did before, I'm using the previous term in order to develop or know the next term. So it seems pretty clear at this stage that each time I add an element to the sequence, I'm using the a sub 1 less. So instead of the second term, I'm looking for the first term times 3. And then on the next level, I'm looking for the second term times 3. And on the next level, I'm looking for the third term. And on the next level, the fourth term. So just like with the arithmetic, I have a recursive formula that involves looking for any given term by using the term just before it, a sub n minus 1, times whatever the common ratio is. And when you think about it, these are actually the more natural formulas for a sequence. In fact, isn't this exactly what I did when I built the sequence? When I decided I was going to have a common ratio of 3, and I started with 1, I said 1 times 3 gives me 3, times 3 gives me 9, times 3 gives me 27, times 3 gives me 81. Same thing with the arithmetic. Once I started with 1, plus 2 gives me 3, plus 2 gives me 5, plus 2 gives me 7, and plus 2 gives me 9. So the recursive formula is really the more natural formula. It's the one we do instinctively when we're building an arithmetic or a geometric sequence. And if we look now specifically at the two sequences I started with, I could say that the recursive formula for the arithmetic sequence would be that any nth term is equal to the previous term, which we designate as n minus 1, meaning the previous term, plus 2 in this case. And the specific or geometric recursive formula for the sequence I set up here would be that the a would be, let me get this erased, would be the a sub nth term is going to be equal to the previous term, a sub n minus 1, times the common ratio, which was 3. So let's do an example. For the sequence 1, 1/2, 1/4, 1/8, 1/16, determine whether it is arithmetic, geometric, or neither. And if it's either arithmetic or geometric, write a recursive and a general formula. So it's clearly not arithmetic because 1 minus 1/2 would give me 1/2, but minus 1/2 would give me 0, not 1/4. And so the only hope for this is that it's a geometric. So 1 times 1/2 would take me to 1/2, and 1/4 times 1/2, 1/2 times 1/2 is 1/4, and 1/4 times 1/2 is 1/8. So I know that the common ratio in this case equals 1/2. Since it's an geometric sequence, I can say that the a sub nth term in a recursive form is the a sub n minus 1, whatever the previous term is, times 1/2. Or if I want to write it prettier, I could say 1/2 times the a sub n minus 1. Or I could write it as a sub n minus 1 over 2. It doesn't really matter how we write it as long as we have a recursive version of the formula. And then we know from the general form that the a sub nth term in the general form is the first term, 1, times r, I think I'll use parentheses here, raised to the n minus 1th power. So there you have it. You have a way to build a sequence starting with the first term and adding the second, then the third, then the fourth, then the fifth. Or we already learned before a way to start with the first term if you know a rule, or if you know either the common difference or the common ratio, to go from the first term to any term you want.